Hi, I'm Miss Hearn. Let's get started. In this video, we're going to compare Euler trails and Hamilton paths. First, we need to define a trail. A trail is a walk that has no repeated edges. For example, here we have the walk from A to C, C to E, E to B, B to C, and C to D. In a trail, there are no rules about the number of times we intersect a particular vertex. Now let's talk about the definition of a path. A walk that has no repeated vertices is called a path. For example, we can go from D to E, and then to B, and then to A. Notice that if we can't repeat vertices, then we can't repeat edges either, because a repeated edge would require a repeated vertex. Now let's talk about Euler trails and Hamilton paths. An Euler trail is a trail that visits every edge. Remember, a trail is a walk that has no repeated edges. If we have to visit every edge and we're not repeating, then we're going to visit every edge exactly once. In fact, the term Euler, which is a reference to a mathematician, always has to do with visiting every edge exactly once. For example, here we have a trail that goes from D to C, and then C to B, and then from B to A, and then from A to C. So we've hit every edge exactly once. Now, by hitting every edge, we also have to hit every vertex, but not necessarily only once. Now let's talk about Hamilton paths. Remember, a path is a walk that has no repeated vertices and consequently no repeated edges either. A Hamilton path is a path that visits every vertex. So if we're visiting every vertex, but we have no repeated vertices, that means that we're visiting every vertex exactly once. For example, we have a Hamilton path from A to B, then B to C, and then C to D. We have hit every vertex exactly once. Now, when we're talking about Euler trails and Hamilton paths, there are 4 characteristics that we're going to look out for. We always want to look out to see whether we have no repeated vertices and whether we have no repeated edges. We also want to pay attention to whether we visit all the edges and/or visit all the vertices. So let's think about Euler trails and which characteristics they must have. By definition, an Euler trail must visit every edge. In the process of visiting every edge, this is going to force us to visit every vertex. Also, since an Euler trail is a trail, we're not allowed to have any repeated edges. However, it is possible that we're going to repeat a vertex. Now let's think about Hamilton paths. By definition, a Hamilton path has to visit every vertex. Since it's a path, it won't have any repeated vertices. That means that there must not be any repeated edges. If there were, that would have caused repeated vertices. But a Hamilton path does not necessarily have to visit all of the edges. It is possible to have a walk through a graph that is both an Euler trail and a Hamilton path, but it would have to have all 4 of these characteristics. We're going to look at some examples where we'll identify whether we have an Euler trail, a Hamilton path, both, or neither. The key to identifying Euler trails is to look for no repeated edges and to look for visiting all the edges. Remember, the E in Euler stands for edge. The key to identifying a Hamilton path is to look for visiting all the vertices but no repeating vertices. Let's look at this example. For the given graph, determine if the walk is an Euler trail, a Hamilton path, both, or neither. We have a walk that goes from D to C, C to B, B to A, and A to E. We have no repeated vertices, and we visit all the vertices. So that tells me that we have a Hamilton path. While it is true that we have no repeated edges, it is not the case that we visit all the edges. So this is only a Hamilton path and not an Euler trail. Now let's look at this example. We have a walk from E to A to B, B to C, C to A, A to D, D to C, C to E, and E to D. We have no repeated edges, and we have visited all of the edges. This tells me that we have an Euler trail. But let's think about the vertices. We did visit all of the vertices. We have A, B, C, D, and E. But we repeated some vertices. We repeated C, for example. So it's not the case that there are no repeated vertices. This tells me that it's not a Hamilton path, so it's only an Euler trail. Now let's look at this example. Determine if the walk is an Euler trail, a Hamilton path, both or neither. We have the walk from A to B, B to D, D back to B, and then from B to C. I can eliminate this being an Euler trail right away because we have repeated edges, and we also did not visit all the edges. So this is definitely not an Euler trail. We did hit all of the vertices, however. We hit A, B, C, and D. But we also repeated vertex B, so there were repeated vertices. This means that it's also not a Hamilton path. So in this case, we have neither. How about this example? We have the path from A to B, and B to C, and C to D. We have no repeated edges, and we visited all of the edges. That tells us that we have an Euler trail. We also visited all of the vertices. We have A, B, C, and D, and we didn't repeat any of them. This means that we also have a Hamilton path. So we have both. I hope you found this video helpful. If you did, please give it a thumbs up. That helps other students to find the video. You can also subscribe to my channel, Miss Hearn Mathematics, for more math videos.